October 2025. An object from deep space. 3I Atlas is tearing through our solar system at nearly 60 kilometers per second. But it's not just speed that has astronomers alarmed. This interstellar visitor has begun to glow 6 times brighter than predicted, unleashing an enormous green coma more than 500,000 kilometers across, larger than Jupiter. And the transformation is accelerating, with its closest flyby to Mars just days away and Earth's window to observe it closing. Rapidly, scientists are racing against time. Why is 3I Atlas behaving like no other object we've seen? Why has its brightness curve deviated so violently from projections? And what's hiding inside that massive green envelope of gas and dust? What was initially expected to be a dim, forgettable dot in the sky is now an unpredictable spectacle that defies classification. The green glow linked to carbon diatomic molecules is more intense than anything seen from previous interstellar comets. But what's causing such a massive release of these molecules? Solar radiation, exotic ices. Or could it be something else entirely? Something not yet accounted for in our models of cometary physics. On top of that, there's growing chatter in scientific forums about a rare structure emerging in anti-tail, a stream of dust pointing toward the sun, not away from it. This challenges the basic dynamics of solar radiation pressure and suggests that electromagnetic forces may be shaping this object in strange, volatile ways. And the stakes are growing. By October 21st, the comet will sink too close to the sun's glare for Earth-based telescopes to track. That means no more data, no more updates. A total observational blackout just as the comet enters its most active phase. Everything hinges on what can be captured now before the 3I Atlas vanishes into the solar haze. Scientists aren't just watching with curiosity. They're scrambling to revise models, simulate trajectories, and align spacecraft orbiting Mars to catch the last glimpses. And the most haunting question still looms. What exactly is this object? A comet from another star system, a relic of galactic chemistry, or something we've never categorized before. This isn't just another passing rock. It's a test of our scientific readiness in the face of deep space unpredictability. As 3I Atlas moves closer to the inner solar system, its behavior is rewriting the boundaries of what we thought we knew about interstellar visitors. And we're watching it all unfold, minute by minute, with less and less time left. As the brightness of 3I Atlas surged unexpectedly in early September, it sent shockwaves through both professional observatories and amateur astronomy networks. The object's apparent magnitude leapt off the projected light curve, prompting urgent recalculations. While the nucleus of the comet remains hidden deep within the coma, what we can observe its reflected and scattered sunlight is increasing at a rate few predicted. Recent measurements place the coma's diameter at nearly 500,000 kilometers, a vast green envelope rivaling the size of gas giants. This green flash isn't merely aesthetic. It's the spectral fingerprint of C2 or diatomic carbon, a molecule rarely observed at such intensity. When solar ultraviolet light strikes these carbon-rich compounds, it excites them, prompting a bright green emission, particularly around the swan bands, at 510 nanometers. But the intensity here is far beyond normal comet activity, suggesting massive, rapid sublimation of volatile materials, possibly ones not commonly found in our solar system. To complicate matters, observers have also detected possible traces of ionized carbon monoxide and cyanogen, which can also glow under UV radiation, adding blue or green hues. But the debate remains unresolved. Is this spectral cocktail typical of an interstellar traveler? Or is 3I Atlas presenting us with a completely new chemical profile? And then there's the speed. As of early October, the object is traveling at nearly 60 km/h and is projected to hit 68 km/h by perihelion, more than twice the speed of any planet in our system. At this velocity, 3I Atlas could cross the distance between Earth and the Moon in just over an hour. It's this combination, unprecedented brightness, unusual spectral signature, and staggering velocity that's drawn the attention of every major astronomical body on Earth. But the clock is ticking. The solar elongation angle, the space between the comet and the Sun from Earth's viewpoint, is dropping below 30 degrees. That's the point where Earth-based telescopes can no longer distinguish it from the sky's glare. For many astronomers, especially amateurs, the observation window has already closed. What's left is a narrow twilight sliver just after sunset, with the comet barely brushing the horizon. Meanwhile, global networks of backyard astronomers are racing to capture whatever final images they can, coordinating efforts across time zones, stacking images, and sharing raw data on community servers. These crowdsourced efforts may prove vital, especially as professional observatories begin to back away due to the risk of sun exposure, damaging sensitive optics. But Earth isn't our only eye in the sky. Orbiters circling Mars are now in the spotlight. With the comet set to pass within 28 million kilometers of the red planet on October 3rd, these spacecraft represent our last best chance for close-up monitoring. Instruments aboard ESA's Mars Express, ExoMars TGO, and NASA's MAVEN and MRO are all being retasked to monitor gas composition-dust interaction and, if lucky, the comet's nucleus itself. With Earth blinded and the Sun dominating our skies, Mars becomes the new front line in the investigation of 3I Atlas. The Mars flyby of 3I Atlas on October 3rd isn't just a moment of opportunity, it's a strategic shift. With Earth-based observations, fading attention has pivoted entirely to a fleet of Martian orbiters. Each one offers a different lens, both literally and figuratively, into the mystery of this interstellar object. The European Space Agency's Mars Express is equipped with a high-resolution stereo camera and the Omega spectrometer tools that can detect chemical traces in the coma from millions of kilometers away. Meanwhile, ExoMars' Trace Gas Orbiter, with its NOMAD and ACS spectrometers, is optimized for hunting elusive gases, CO2, H2O, and potentially exotic volatiles never before recorded from an object like this. NASA's MAVEN brings its ultraviolet spectrometer and plasma detectors into the equation, monitoring how solar wind interacts with the dense coma of 3I Atlas, a dance of particles rarely witnessed at this proximity. And perhaps the most ambitious gambit lies with the Mars Reconnaissance Orbiter and its high-rise camera. While it wasn't built for tracking fast-moving targets under perfect conditions, it might just capture the nucleus, something Earth-based telescopes haven't achieved. Yet, despite these efforts, nothing is guaranteed. Every mission must balance pointing limitations, data bandwidth, and rapidly changing geometry. Some instruments are simply not designed to track objects moving at this velocity or crossing the solar limb. And no agency has promised full-time observation. So what's truly at stake here, it's more than just images. The data gathered could rewrite what we know about interstellar comets. Unlike Oumuamua, a dry rocky shard, or Borisov, a more traditional water-rich comet, 3I Atlas, exists somewhere in between. Its extreme velocity, explosive coma, and peculiar green emission challenge the neat categories astronomers have used for decades. And now, a new anomaly enters the stage, the anti-tail. A thin dust structure pointing toward the Sun, seemingly defying everything we understand about cometary behavior. Traditionally, a comet's tail forms as solar radiation pushes dust and gas away from the nucleus. But in late September, some observers began noting a faint counterstructure aligned with the comet's direction of travel. This so-called anti-tail suggests that charged or large particles may be moving ahead of the comet, possibly influenced by electromagnetic forces or shaped by a unique viewing angle between the comet, the Sun, and Earth. Plasma physicists propose that the hypervelocity of 3I Atlas is creating chaotic electromagnetic interactions. As dust grains are ejected from the nucleus, some may become electrically charged and trapped in fields shaped by both the solar wind and the comet's own outgassing. Under the right geometry, these particles can align into sunward spikes, forming an anti-tail visible only under rare, perfect conditions. The Earth, for a brief moment, lined up just right. But without peer-reviewed images, the debate remains open. Are we witnessing an authentic anti-tail on an interstellar object, or is it an artifact of perspective and image processing? Forums across the astronomical community are ablaze with speculation, raw footage, and heated exchanges. And perhaps this is the point. 3I Atlas is not just a comet, it's a catalyst, a trigger for scientific debate, community collaboration, and re-evaluation of what deep space visitors truly are. This event is revealing gaps in our detection systems, limitations in our interplanetary instrumentation, and assumptions baked into decades of cometary science. The object is forcing questions we're not ready to answer. How common are these fast, active interstellar objects? Have we missed others? And how do we distinguish them from local anomalies before they vanish forever, as it hurtles toward the Sun, trailing mysteries in its wake? 3I Atlas becomes more than a comet. It becomes a mirror reflecting the edges of our cosmic ignorance. As 3I Atlas nears its solar close approach, its perihelion, everything begins to fade. Not just its visual brightness, which models predict will plummet sharply as the coma shrinks and disperses, but also our ability to follow it. Once it slips behind the Sun from Earth's perspective, no direct observations will be possible. No imaging, no spectroscopy, no trajectory updates. It will vanish into the blinding void just as it enters what may be its most chemically and dynamically active stage. For many amateur observers, the final days of visibility are already behind them. A telescope with at least an 8-inch 20-cm mirror is now the bare minimum to detect even a faint smudge. Only the most sensitive digital cameras operating under pristine dark sky conditions have any chance of capturing useful data. This is where the citizen science networks step in. Discord servers, private databases, real-time updates, flowing through forums, and crowdsourced light curves built from amateur telescopes worldwide. These volunteers have kept 3I Atlas alive in the public imagination, while professional instruments are pulled offline one by one due to solar interference risks. The science hasn't stopped, it's just shifted to a new arena. But the deeper significance goes beyond the data. 3I Atlas has reignited global curiosity about interstellar objects, a field that didn't even exist until 2017. The green coma, the anti-tail, the Mars, Flyby, the extreme speed, all of it forces us to rethink what we expect from visitors born outside our solar system. These aren't just icy bodies drifting aimlessly through space. They are messengers, bringing chemistry and motion from unknown corners of the galaxy. And they might be far more diverse, active, and complex than we ever assumed. Unlike Oumuamua's silent flyby or Borisov's familiar behavior, 3I Atlas is aggressive, flashing, flaring, changing course, and breaking the rules. It resists easy classification. Is it a rogue from a collapsing system? A fragment from a binary star's ejecta? Or a member of a broader class of hyperactive interstellar travelers we've only now begun to recognize? Even as it retreats from our instruments, the questions it raises grow louder. What triggers its outbursts? Why such extreme carbon signatures? And could there be more like it already on their way? For now, the story ends not with a bang, but a blind spot. The final data packets from Mars orbiters may trickle in over the next weeks, analyzed frame by frame. And then silence. But silence isn't the same as absence. Somewhere beyond the reach of our telescopes, 3i Atlas continues on its path, reshaping itself, and perhaps reshaping how we understand our place in a galaxy full of icy travelers. The question now is when the next one comes, will we be ready to listen?